spontaneously?
Maybe for mass distribution, equal mass distribution. For a die to be, it needs to be what would you say, loyal, or if it is
Loyal.
And it needs to be more. I think the probability of getting 1/6 is more when every side it is balanced.
Why?
It is counterbalanced. It has.
You are reached very close. I agree with you. You have seen that toy where you hit the toy, it falls and comes back again. Anything which you throw, it will always land on the heavier side. So if the dice, what is the reason for dice? That the probability of getting 1, 2, 3, 4, 5, 6 all are same. And anything which is moving and rotating, if one side is heavy, it will fall on that side. So in order for all the rotating faces to be the same way, the number of dots have to be same on all the sides. And that's why spinning, it will always spin on 7 on both sides. And that's the reason the outcome will be neutral. So what you do is, put wax on one side of the die. You can do that at home. Deposit wax on that as 6. Throw 50 times. More than 25 times you'll have 1. Because it always land on the heavier side. And that's the reason I told you, never play with the die which is 1/6. Because then you will know which side is heavy. Where the number of dots are heavier. 6 with 5 opposite, outcome will be 5 for most of the times on the die. Because that's the heavier side. 6 will be the heaviest, 6 and 5 combination will be the heaviest. So in order to keep that also balanced in mind, that was the design, that once everything has to add up to 7. Okay. What was the other one we were discussing? Design? Water. What's the design there? You have been taught in the class that solids have, which has the maximum density? Solids, then liquid, and then the gases. That's a very universal. In case of water, all of you know, solid water, at home you have to take ice and you put it in a glass of water, what happens? Ice floats. You're very happy, you get cold. Shouldn't it bother you that ice is solid, should have more density than the water, and it should sink? No, it floats, it gives good taste, it chills everything down. Why worry about it? It should strike you. That's what I'm trying to tell you. Something you know is wrong. Cycling with handle holding, putting ice in water, ice should sink. Solid is been told to have more. The water is a special case. You don't tell me it's hydrogen bonding, that the orientation of that makes it more porous. I'm not interested in that. But that solid water has less density than the liquid water. What is the design in that? All your, if this solid water would have normal density as any other solid, whenever you have low temperature, all your lakes and rivers will freeze. Then it will be heavy, it will go down, water will come up, that will freeze, the whole thing will freeze. Everything aquatic will die and you die. All anyway related to each other. So what happens in winter? The ice forms. Ice is lighter than water, it floats on the surface. And ice is a bad conductor of heat. It insulates the lower layers. And then you have a beautiful way of surviving all the aquatic life. And that's the reason you have been told. A lot of things have been told to you, then never worry about why this has been told. It's been told, don't walk on an unknown terrain on ice. They tell you whenever there's a ice, somewhere they say if you don't know the place, don't walk on it. Because you have no idea whether you're walking on a water body or you're walking on earth. By chance you're walking on a water body, the ice will be very fragile. You put the weight, it's going to break. You are going to go into a water which is 4 degrees. You need to know how to swim in that 4-degree water. Plus, the moment you fall, you are going to go somewhere else. On top of it is closed. You have got only as much second as you are trained to swim in 4-degree water before you can get your thoughts back and try to break the earth. And that's the reason it's been told that don't walk on ice in an unknown terrain. Because you don't know whether you're walking in a water body or you're walking. It's a very clever design nature has it. Or everything, you think everything has a design in that. Why do we put water in earthen pots? And water in the earth, actually if you take underground water, it's more cold in summer and then winters. But you put in a metal, it's other way around. Why? Why earthen pot water becomes cooler than the Metal pots? It's a evaporation. It has pores. Through pores the water evaporates. Then what happens? Why evaporation leads to cooling? One at a time. Everybody say. Raise your hand. Why evaporation has to lead to cooling?
Let it evaporate, take the energy from the other.
There is an endothermic. You need to provide heat to vaporize it, and that energy comes from the neighboring molecules. So they lose and one gains. Okay. Same thing. You know talcum powder. What is talcum powder? Is SiO2. What is sand? Silica is SiO2. Everything. But you don't take sand and rub on your face. You spend so much money on water, on talcum powder. You know that? Why? Take a sand and it's chemically same and put it on your face or your body. Why? Oh, that's just the sand. You can spray sand on top of it. That's just a fragrance. That is added. Bulk is still the particle sizes. So what? That told. What's the significance of that?
Size of this grade of
See, basically, the skin is actually not smooth, but it has the little.
It has pores.
Yeah, pores.
So if you have to design a talcum powder, you have to first ask for what you want for your body. And your body is porous, your skin is not smooth. And if you know the pore size, then only you can design the talcum powder, because you need to design something which has a particle size smaller than the pores. So that when you put this, it fills the pores and you feel a smooth feeling. Anything bigger than the pores will not fill it, and you will feel the friction. That's what if you put sand, it gives you friction. If you put talcum powder, it gives you smooth feeling. That is because your skin is rough, and you require particles which are smaller than that to get over that. And you know why skin is porous? Because your body temperature has to maintain at 37. That's the reason in winters, what do you do in summers? Summers you eat less, winters you eat more, isn't it? Why? Because the temperature is low outside and food generates heat. Okay, you pass more urine in winter. Why?
because the sweating is less and cooling is also less.
No, sweating is less, but why to pass urine?
Water needs to get out, right?
Yeah, so if you don't pass it, then it will evaporate. And evaporation will cause cooling and the whole process will go against you. So all these things which everyday life is very connected, and you need to see that everything has a design. And that has to come with it.
If your skin has pores to keep your temperature down.
One of the function, not all. One of the function, main function.
Then we use a talcum powder to defeat the purpose of your skin.
That's the reason they say you should not. But if you want to smell good and look good, then, so you said that I'll go in air condition, so my body doesn't need to function that way. But go to Delhi in a 50 degree and put talcum powder and come out. You will see the effect. But you go to an air conditioned building, you don't have to evaporate. Temperature is maintained there. Use whatever. So all these cosmetics are used for the lavish places. You don't go to a slum on a 40 degree and 80 degree and then put talcum powder there. So it has a meaning and a purpose. If the purpose can be done by conditioning the air, you can use anything you want. Then that particular process you don't require. And that's the reason people in the colder places are generally more fatter than the people in the warmer places. Because to maintain the same body temperature, they need to eat more. Because food produces heat. I'll give you another experiment now. Very interesting. Where is that gone? It's here. So I'm going to do it in front of you because it's I've got completely dried up. So I'm going to do this, just watch this and then we'll discuss it just, okay? You see anything on this? What do you see? 7 of diamond. You see anything on this? is 7 diamond. We can turn it lights here. There's nothing on this. It is 7 diamond. Yes? There's nothing on this. This is 7 diamond. Yes? What is it? 7 diamond? Not you can see? I'll do this side. What is Now, you have seen this, that when I blow on it, 7 of diamond comes. So there are two possibilities, that I am a damn good artist. And every time I blow, I create 7 of diamond. People are laughing, eh? Second possibility is, it's already there, and it's not visible to you. That was my first question in the first half I asked you. What makes something visible? Now you know 7 of diamond is there on this, and you don't see it. When I blow on it, it comes in. I'm not interested in why it comes in. That's easy to explain. I'm interested in why it is not visible.
That it is rich with HF.
One at a time.
Okay, it is rich with HF.
Forget about that.
Okay.
Why it is not visible?
Because we have a micron level sensitivity. The distance, the dip is of a nano order or something, which is less than. So it is not transparent to that. Sorry, it is transparent to that.
What is that?
Anything of the micron level we can see. Below the difference.
Oh, some micron you can see. Will get some micron but they are opaque. You can see that's right. You can have some micron be less than 800, 700 but almost 0.5, 0.8 actually.
Up to micron level you can see. Below the difference.
No. Light doesn't have to come. There's nothing else. I mean, we see all these objects.
Reflection.
No, you see this. Now you see the glass. You see the glass. Glass is not reflecting. But you're not seeing 7. That's what my question is. Reflection, refraction, scattering are one of the process of many processes of seeing it. What's the criteria of seeing it? What's the minimum criteria? So if something blocks the light, that image is very strong. Something, I'm giving you enough clues now. Something which transmits the light, image is weaker. Something keeps on transmitting more and more light, it becomes weaker and weaker. What's the criteria for something to be visible?
Scattering.
It has to be opaque.
No, opaque is a very strong image. This is not opaque. You see this? This is not opaque. No, it doesn't at all. The criteria to see that is the path of the light has to change. If the path of the light does not change, you will not just little bit move. It won't fall because there's a connection, but still be safer. Just safer, you just change to one or to other. So the criteria for seeing something is path of the light has to change. If the path of the light does not change, so if you take a tennis ball or take a rice and hit it on a football, what will move? Rice. If you take football and hit it on rice, rice only will move. So if the, light has a size. So if light has a size which is moving with a direction certain, for it to change its path any significantly, it has to interact with something of comparable size. Yes? And if the size is interacting with few nanometers, what's the size of the light? Size of the light. You all should know, what are you talking about? Of the order of angstrom. Size of light. Light, visible light.
400 millimeters.
Yeah, but you're not teaching the kids. They should all know. Visible light 400 to 700, 800 nanometer. Nanometer is the size. Nanometer is the size. Now, if it interacts with something, you lot of you must have seen gold nanoparticles, silver nanoparticles. They look solution because they are 5, 4, 3 nanometer. Anything which comes in here 100, 200 nanometer, light will start interacting to get path change. Anything 500, 600 nanometer, it becomes more in scattering. Then anything becomes more bigger, light can completely block. For anything to be visible, the path of the light has to change, and path of the light can be changed only when it runs into hundreds of nanometer size. And that's the reason air is not visible. What's the size of air? Particles. This nitrogen, result is nitrogen. Put few angstrom, even if you say 5, 3, 4 angstrom, and triple bond, and look at 1.2 angstrom or whatever. Yeah? So that's the reason it doesn't change. And so what we have done in this is, we have created this 7 of diamond in the forms of dots. Okay? And those dots diameters are 30 to 40 nanometers. It won't be visible because it won't change the path of the light. And you know when you etch, if I take glass and break it, what happens? Do you know? If you take a glass, just let me know 10 minutes before when you close it. 10:45. Okay, sure. Done. Just so when do you break the glass? What are you doing it? Does anybody wonder? If you break the glass, what actually you are doing? I hope all of you have broken glass at least.
Changing the direction.
No. What are you breaking? What is glass? Is it SiO, SiO, SiO2? So when you break it, are you breaking SiO bond or what are you doing? So what are